Hello everyone and welcome back to our series about teaching maths in the FET phase. Before we get to our panel discussion, let's first take a look at our video. This lesson's focus is on the applications of sequences in series. In particular, it looks at problems involving finance and banking, interest and investments, appreciation, depreciation, and loan repayments. The lesson will then move on to showing learners how to deal with a typical exam question. The intended outcomes are: solve a problem involving inflation, depreciation, interest and loan repayments and use the results to make an informed choice, and to solve a typical exam question about sequences in series.
We are going to solve problem involving inflation, depreciation, interest and loan repayments and use the results to make an informed choice.
The learners are asked to solve a problem where a company must decide on buying a fleet of 10 cars. They need to determine whether it is cheaper to buy the vehicles in cash or on hire purchase, taking into account inflation, depreciation and interest. This question is about the application of sequences in series in financial situations. It is also about how to deal with examination questions in sequences in series.
Each member in the group just read it through.
The teacher first asks the learners to read and understand the question thoroughly before attempting to answer it.
You multiply the price with 10 cars. Cash.
But it soon becomes apparent that many of the learners are struggling to understand the question.
Sorry to disturb you. Maybe one may explain some of these words so that maybe you'll understand. Inflation. This word is from the word inflate. So if something is inflated, it has increased. The language plays a very major role in a sense that, in mathematics, questions, although we deal with numbers, but questions are being asked in English. So in such an environment, kids, they're still struggling with the language. So the lesson doesn't go as you plan. You sometimes deviate from what you have planned because you have to explain, code it down, and even the language, you have to switch in Zulu and go back to English, so that the kids will understand. The percentage, if we talk about percentage, is something over 100. Everything, if it's 8%, that is over 100. I was just giving you the hint, so just go.
After clarifying the terms, the learners are now ready to summarize the different aspects of the question. To answer the questions on the worksheet, they need to know the cash price for 10 cars, the usual price without discount, the time period they'll be kept, the depreciation over that period, depreciation as a ratio, and inflation as a percentage and a ratio.
In each year, the depreciation was 12%.
After the learners are done, the teacher can summarize the different aspects of the word problem.
Who can tell us the cash price for 10 cars? And tell us, how did you work out? The cash price is?
1.2 million.
It's 1.2 million.
Yes.
How did you work out?
I multiply the price for 10 cars with 10, which is 120,000 times 10.
Okay. Time, that is period to keep cars. The period is 5 years. This is what you should get on the period, 5 years. Okay. Depreciation as a ratio? Yes.
12 is to 100.
12 is to 100. Inflation as a ratio? Megas?
8 is to 100.
8 is to 100. This is what you should have in your column there. That is going to help you. And you go through to the next questions, where it's written solving the problem.
How much in this?
Having now defined the different aspects of the problem, the learners can go on to do the activity. They have been asked to find the resale value after 5 years, the price of a similar car after 5 years, loss of potential investment earnings over 5 years if the cars are paid for in cash, the cost of repaying the loan if the cars are to be financed, and what advice they would give to the company, that is, what is the cheapest solution for them.
That's a question that you must ask yourself. How to work out the ratio in a geometric sequence. As you give them a work to do in groups, so you must rotate and see that everyone in the group, every member in the group participate, you see. And at the end of the day, each and every member of the group must get the information.
Basically, the most important method when teaching mathematics or science is to allow learners to do these things. So allow them to, actually it should be activity-based. Learners should do the activities and discover the concepts.
The learners are given time to find the answers, and the teacher then summarizes.
So starting in the first question, solving problems, that's the first question, which says, what is the starting value of 10 cars? Tell us, yes?
1.4 million.
What will the value be after 1 year if the cars depreciated 12%?
1,232,000.
How did you work it out? With the formula.
The learners have to use the formula for depreciation to solve the problem. In this formula, A is the final amount, P is the principal amount, R is the interest rate per annum, and N is the time period in years.
100 to exponent n. So you work out from that formula, okay? If you regard these two values as the first two terms of the geometric sequence, what is the common ratio link the depreciating values? Maybe first we have to start by asking ourselves, how do we work out a ratio in geometric sequence?
First values divided by second values.
The learner has reversed the terms for the common ratio, so the teacher corrects him.
With the first term. So, in other words, here we have to divide the value that we have, this value here. We divide it with this value, so that we'll work out the ratio. And then what is the answer here?
0.88.
This is our ratio, 0.88. Now, the next question, write down the general term of the depreciation sequence of the values. Do you have...
Having established the common ratio from the formula for depreciation, the learners can now use the general geometric term to answer the questions on the worksheet. The general geometric term is used to first calculate the value of the cars after 5 years. The further questions on the worksheet can be answered in a similar way. This is the cost of new cars in 5 years due to 8% inflation. They also work out the lost investment earnings if the cars are paid for in cash. And finally, the cost of repaying a monthly loan over the 5-year period.
This is not just only numbers, but this helps you to plan properly over a long-term period.
The learners now have to evaluate these results and decide whether it would be cheaper to purchase the 10 cars in cash or with finance. This is a complex decision, and they will need considerable guidance from their teacher to find the answer.
In an arithmetic,
A class now focuses on strategies for dealing with exam questions. One example is, in an arithmetic progression, the 8th term is twice the 4th term. The sum of the first 3 terms is 12. Determine the first term.
let the 4th term be x, so it means your T4.
The learners need to use the appropriate arithmetic formulas to solve the problem. The teacher should focus on how to solve each part of the question. If we take the general term of arithmetic sequences, we can translate the given information into equation format. This is clearly a situation for simultaneous equations. The second piece of information translates as follows. We can now substitute the answer from the first equation. The first term is thus equal to 2.
In actual fact, what we're trying to do here is that how do you interpret the statement and you write it down using the formulas, okay? So this is how you interpret. You take each step, you take each part as it comes.
The main thing is conceptual understanding to both mathematics and science. Once you understand the concepts, once you understand how you do it, you'll then apply it to the next level. Mainly with the learners, they fail to understand that sequences and series are things that are around them. So the best will be for educators when they design these topics is actually the activities on the topic. They should look at things that are around the learners, the immediate environment of the learners, to make it as easy as possible.
Now that we've seen our video, time for us to welcome our guests. We've got Paul Appelsamy from Diversity and Transformation Solutions. We've got Smangaliso Twala, who's an independent maths consultant. And we've got Taska Matlejwane from Pafokgang Secondary School. Thank you for joining us. The first question, let me start with you, Smanga. Do you think the question relating to the cars was appropriate for the learners?
For this kind of learners, I wouldn't say so. Even the teacher himself is also saying in the video that we need to take things that are relevant to our children in our immediate environment. Now, this teacher did not do that. This is in a rural area in KwaZulu-Natal, and they're talking about cars and expensive cars, and it's unlikely that they might have cars in the place where they are. And so I wouldn't say this was a relevant or appropriate for the learners, the issue of the cars.
Okay, Paul?
Yeah, I think in terms of the example used, the relevance here, has got to be contextualized. Urban-rural setup, environmental issues. Why not just take things like, purchasing of goods or purchasing of food items, which we could have perhaps, captured very nicely into a problem like this. But obviously there are several issues that are being raised in that problem. There's several concepts which I'm not so sure have been put on the table previously. There's inflation, there's depreciation, there's interest. Now one appreciates the overlap with perhaps educational, economics and management sciences. But I'm not so sure it doesn't come across as if this is being achieved well enough in this particular example. So I do think that with this example thrown in, it somehow seems to create a lot more confusion because the responses don't seem to be flowing from the kids.
Taska?
Yes, I would say yes and no. The example can be very good in the sense that, for starters, I would say it's dangling carrot in front of learners. Every learner wants to have a car one day. And therefore, it stimulates them to say, yes, I need to understand that because I need a car in the future. And then no, in the sense that it's not their immediate environment, but taking it as an example, as they've already come about it, I would say it creates the opportunity of connecting maths and coming up with the relevant maths. And I also like the aspect of cross-curriculating. It cross-curriculates so well and maps well with what OBE is all about. And I like it for that. And I would also think of touching on an aspect of business ethics, because these learners know that cars do depreciate. But the car which I saw it for 100,000, the following year when it's sold as a second-hand car, it's sold maybe even for more than 100,000. So I think it's going to produce responsible citizens. When they go into business, they know how things are handled.
Learners who understand what they're going into.
That's right.
Now, how important is the issue of language for second language English speakers in understanding the topic of sequences and series?
I would say for both first language speakers and second language speakers, for me, I find language very important because there is ordinary English and there is mathematical English. And whether you come from the background of first language or second language, you need to learn the language which is used in mathematics. There's a register for maths concepts, And the discourse in mathematics is different. And all learners, irrespective of their background, they need to be properly initiated into maths discourse.
Yes, certainly. Maths, sciences, a universal kind of language which is applied widely. One has to have that kind of understanding of those particular concepts that are raised there. Often African languages don't provide enough to support the understanding within the particular terms and references that are made in those sciences and maths. And yes, I think we need to talk about contextualizing. It's obviously a problem that's there for a while, and I think teachers are again saying they have to go across languages, talk in an African language and in English to kind of get the message across. This needs to happen. In exam type setup, we've also seen the kind of confusion that kids present when they write down answers. They don't understand the question, and it's really the language that sometimes is very, very problematic.
Language is very important, and so it's very important that teachers make sure that learners do understand what they are talking about before maybe they could move on to something new.
Okay, Paul, in handling this topic, now isn't there a danger of learners becoming hooked on formulae instead of genuinely understanding the nature of the two kinds of sequences?
Certainly. I think when we generally approach this, we're talking about, A, we're talking about D, we're talking about N, we're talking about the nth term. And all of these are thrown at kids in a way that, yes, find this, it's a recipe kind of format. Find 1, 2, 3, and then plug it into the formula, and you generate a result. Now, I think that is definitely problematic. I think, that is why the deductive kind of reasoning that we talk about here is crucial. Kids need to look at a problem, from that problem generate a clear understanding of what is being asked, and then, of course, relate to perhaps particular formulae. Now, formulae can be both destructive, in terms of, the way people work, and constructive, because once you efficiently understand questions, once you are able to relate, the formulas can be there to assist in terms of generating quick results, okay? And then, of course, an appreciation and understanding of where those formulas are derived is crucial. And often that is what's lacking. If you go back and ask a kid, okay, look at this formula, where was it generated from, how do we come up to it? He can't bring you up to that formula. Why? Because the conceptual design up to that point was wrong. So I think if that is intact, then the formula definitely acts as a constructive kind of a mechanism to actually generate speed and efficiency with working.
Okay, so it's got to work together.
Yes.
Taska?
These formulae need to be generated by learners and understand where they come from, because otherwise it will boil down to the question of instrumentalizing mathematics, plugging in, getting answers, and so on. And as a result, that's why you find them in practical situations in schools where they even plug in wrong formulae because they don't know how those formulas came about. Now, once you come up with the necessary procedures of creating this formulae, the formulae becomes much better connected and they'll make better sense for learners.
Okay,
formulas can also be very, can actually cause children not to understand things and stop from thinking. If you just use this and it works, just like a little computer, just plug it in and you hit buttons and it works. But the understanding is not there. And so in this particular instance, we need the understanding, and then and we generate the formula ourselves, and then it will be easy to understand. And even in exams, then it will be easy to understand it, not to forget the formula.
Okay, and talking about exams, Taska, do you think the teacher's advice about how to handle exam questions was adequate?
I don't think really the opportunity was properly utilized. That opportunity was underutilized because I've personally missed it. And I would therefore say he needs to have gone further.
Okay, Paul?
Yeah, exam type questions, differ, they vary. One could have now used this opportunity to show responses to kids that were typical responses from children, and show where they missed, conceptual, thinking. That wasn't there. There may have been words given, but I think if you go back to exam type questions, and we found this over the years, kids respond in a particular way and for particular reasons. And it's an understanding of their thinking that's important in terms of designing and creating our kids to think in a more open way about the way they answer their questions. So I think we could have used particular examples and particular responses and shown where kids go, offline, and then draw them back to the center and say, guys, this is how we follow through the thinking, okay? And the comprehension in terms of this thing really needs to get right. We need to get it right. You know, you can't sit in terms of a question and say, right guys, here's a format. There's no format. One has got to apply your mind, and the way you apply comes to your comprehensive ability, through your understanding. And then of course, the actual theory needs to be well sounded.
Okay, Smangalisa?
Yeah, I think it would be advisable to give them the general understanding of mathematics and not actually focus on the exam questions per se, because then you're forcing children to be always thinking about the exams and not see things other than exams outside the classrooms.
So in other words, you want to make them think of it in
Yeah.
everyday circumstances and
In
not
everyday
necessarily just in
circumstances.
exam situations.
Exactly.
Okay. Any other issues, Paul?
I think sequences and series as a topic has got definite objectives that we need to achieve. And I think clear plotting of these objectives and then a deliberate attempt at how to arrive at these things is what's needed. I think what we had missing was a series of applications that show a kind of progression through the thinking in sequences and series. I would say that was missing. I would say that you know, the problem didn't work well. For one or two reasons, it didn't work well. It came down at a level where it was not understood. So sure, you can try to apply your mind, but make sure that the context within which you apply is correct. So here you bring a problem to a classroom, and maybe it just caused more confusion than actually add to the understanding that these kids had.
Okay. Taska?
Yes, I would say this was an opportunity when you come to sequences that should have been exploited fully, because it's so applicable in life. It touches life in many aspects, and those should have been highlighted. And also the example, the choice of examples, sometimes you need to be very cautious when you choose them, because they can be misleading. Like for instance, I remember as one example was quoted of T4 is X, therefore T8 is 2X. Learners can think that the 4 and the 8, the way they are related, that's the way the outcome is also related, and which is not true. So examples must be carefully chosen.
Okay. Smangalisa?
The topic itself was okay, but there were too many things that the children had to deal with. There were too many concepts that they had to battle with, like depreciation and inflation and so on. And they did not actually understand those. And so to deal with such a problem, plus those other things that the children didn't understand, it creates a big problem for the children and confusion as well.
Are you saying maybe depreciation and inflation also should have been a lesson on its own?
I'm thinking like that. Maybe those terms or those things should have been dealt with earlier, so that then the children should actually flow with the whole thing.
Make them understand it better.
Yeah, certainly.
Okay. Well, that's how we come to the end of the session. Thank you very much for joining us, our guests, Mangaliso, Paul and Taska. And thank you to our viewers for joining us at home and at schools. Do keep your eyes peeled for Module 22 coming up soon. Thank you for joining us. Goodbye.